This is Pre-Calc 12, Chapter 2.2. We're going to be looking at graphing rational functions. In Pre-Calc 11, you did graphing of reciprocal functions of linear and quadratics. So we're taking it up a notch. Rational expressions have the form p of x over q of x, where p and q of x are polynomial expressions. So let's go over some definitions. This red dotted line is the horizontal asymptote. We use the abbreviation HA. This blue line is dotted is your slant asymptote. And you abbreviate this SA. In the book, it also refers to it as oblique. I think slant is easier than oblique. For these two asymptotes, we're considering what happens at infinity, not anywhere in the smaller values. So really, this red line could have come up and down. So it approaches the horizontal asymptote or approaches the slant asymptote, but doesn't actually touch it or reach it at infinity, not at the smaller values. And this last one here, you've done this last year, is a vertical asymptote. Vertical asymptote is slightly different. There's no values that touch it. And when we say no values, it's no x values. Here we're looking at y values. And for the slant asymptote, we're just looking for the line. It's not going to touch the line at the infinities. Okay, we're going to go over a few things. The rest you need to learn on your own. Vertical asymptotes occur at the zeros of the denominator. So how many vertical asymptotes are possible if q of x has degree n? That's the question you want to think about. This is the property. And when does a rational function have a horizontal asymptote? And just a slight hint, you want to compare the degree of p with the degree of q. Or you can also use degree of the numerator, degree of the denominator. And here's a challenge question. When does the rational function have a slant asymptote? Again, we want to compare the degree of the numerator with the degree of the denominator. And how can you tell what happens at the ends of the curve? So how do you know it ends up on this line? How do you know it ends up here? Does it end up at positive infinity or does it end up at negative infinity? How do you know what happens at the ends? And you want to look at leading terms of the numerator and denominator. And you'll need to know the definition of a hole, and that's when a point is removed from a curve. So what do we mean by that? If I draw a curve and that point is removed, then that's a hole. However, this is not a hole. It's called a jump. So when do holes occur? Can they occur with vertical asymptotes? If you understand all that, you're ready to start on the homework. If you need a few more hints, then keep watching. So in the lab, you're considering group 1. And with group 1, when you see a polynomial, you want to factor it. X minus 2, x minus 1, x minus 2. We can cancel out these terms. So what we have left is, that's a plus, x plus 1. We have a hole. And the hole occurs when the denominator has an NPV. So x minus 2 equals 0, x equals 2. And normally it's good to specify the coordinates of the hole. 2, 1, 2, 1, 2, 3. So coordinate of the hole is 2, 3. We want to also notice that in group 1, this one doesn't have a vertical asymptote and it has no horizontal asymptote. Group 2. I've factored this one out for you. Nothing cancels out here. So we have NPVs. X equals negative 3. X equals 2. And this time, negative 3, 2, these are vertical asymptotes. We also want to note that here we have a horizontal asymptote, y equals negative 1. And if we look at the leading terms, that and that, we have x minus x squared over x squared. That's negative 1. So we can calculate the horizontal asymptote by dividing the leading terms. And we also want to note that there's no holes. Sorry, I want to just go back to this one. Your calculator won't always show the hole. You always have to look for the NPVs. Last one. We factor, and there's nothing that cancels out. We have NPVs. X equals negative 2, x equals 3. And we get that from these two factors. So we have negative 2 and 3. Here we have x equals negative 3, x equals 2. Okay, so these are vertical asymptotes again. And your hint was nothing cancels out. Nothing cancels out. Something cancels out. We also have a horizontal asymptote. Y equals 0. We divide the leading terms. Okay, and what we want to do is consider large x's, so large values of x's. And we also want to note that there's no holes here. And that completes this lesson.